Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous two lectures, that is gravitation and mass and weight. Now in this lecture we will study about thrust, pressure, force of buoyancy and Archimedes principle. Guys, what is force of buoyancy and what the Archimedes principle say? We will see it by physical experiment in this lecture, and we will also discuss some numerical problem based on pressure and buoyancy force, and how the application of Archimedes principle is being done in our daily life. Okay, so guys, first of all we here start with weight. Guys, here weight. Okay, so weight, if we are talking about the earth system, okay, so we are measuring the weight of the object on, or you can say near earth surface. Okay, so weight of an object is force of attraction between object and earth. Okay, so you can say how much force of gravitation apply by earth on object is known as weight of object on earth surface. Okay, guys, see, this one is a earth, suppose. Okay, or now this one is a center O, or this one is a, say, object whose mass is, say, m. Okay, here center of earth and mass of earth is me, and you know radius of earth is, suppose, re. Then you can see our earlier lecture that force of attraction between this object and earth mass me equal to g m me or re square. Okay, so we can write here m. G is a gravitational constant. We have already discussed in our last lecture in gravitation. Okay, so guys, this G is a gravitational constant. Its value is 6.67 10 to power of minus 11 Newton meter square kg to power of minus 2. Okay. Here mass of Earth is 6 into 10 to power of 24 kg and Re equal to 6.4 into 10 to power of 6 meter, okay, or 6400 kilometer, okay. So guys, next we can write here m into g, where g value is gme or re square, okay. So whenever you put all these value, you will get this value is this one, okay. So this is force of attraction acting between the object and earth. So this force of attraction in physics is known as weight of the object. So guys, now you understand why we write here weight of an object equal to mg, okay. So guys, now next we will here discuss about thrust, okay. Guys, thrust, it is sum of all the forces acting perpendicular or normal to given area, okay. So suppose here guys, this one a given area which is uniform, okay. Now this force is acting like this, okay. So the angle between this surface and this force, okay, is 90 degree. So such type of force is called thrust, okay. Now the next one is a pressure, okay. So pressure, guys, you can see, suppose your feet is on gravel surface, okay. Now I assume 1 feet, okay. This one is a gravel surface, okay. Now this one is your feet. Now consider another case. This one is a grass surface or your feet is like this one, okay. So grass surface, okay. So in which case you will get more pressure on your feet. So you can say, sir, when I stand on the gravel, then I will feel more pressure on my feet, because here see the contact point is very less in comparison to grass surface, okay. So guys, you can say pressure is inversely proportional to area, okay. Now you can see this one by an example also. This one is a, guys, pencil, see it tips is here sharp, okay. Now when I press this pencil like this one, okay, so what's happened, you can see effect here. The pencil try to pierce my finger, okay, the edge which is sharp, okay. Or now see this surface is more, so we could not get more effect of pressure in this finger, okay. So you can say, sir, pressure is inversely proportional to area. Okay, so guys, that's why the edge of knife is sharp, so we can cut easily the vegetable. Okay, now so here we can define pressure in words. Suppose thrust whose value is F distributed uniformly in uniform area A, then pressure per unit equal to thrust divided by area. Okay, so guys, you can say the unit of thrust is in Newton. It is also a kind of force which is acting normal to the surface, or area is defined as meter square. Okay, then it is Newton per meter square, or the SI unit of pressure equal to guys PA. Okay, so if 1 Newton of thrust is distributed uniformly in 1 meter square area, then here force 1 Newton by 1 meter square, pressure equal to 1 Newton meter square. Okay, or you can say 1 Pascal. Okay, so unit of pressure is now guys in Pascal. Okay, so you can say, sir, where we use this pressure technique. Okay, so you can see guys, under the railway track there are concrete sleepers. Okay, so when heavy train is moving, then contact between the track and rail wheel is very less. Okay, so for distribution of pressure we put a concrete sleepers under the railway track, or you can also see in your daily life when you examine or see the suitcase. Suppose this one, then handle width is more, so the contact area between the handle and your palm is more. Okay, so you will get a little pressure on your palm. Okay, these are the technique to minimize pressure on our daily life. Okay, so for your more clarity, see one numerical question. See a question: a brick having mass 6 kg and dimension 20 centimeter into 50 centimeter into 10 centimeter placed on table top. Okay, find pressure exerted by brick when contact area with table top is first 20 centimeter into 50 centimeter and second case guys 15 centimeter into 10 centimeter. Okay, so solution guys, see this one is a table. Okay, now these are the legs of the table. Okay, now suppose one brick, okay, is lying in this orientation. Okay, so you see here in mathematics, okay, when the dimension is given in volume, okay, then this one is length, this one is width, or this one is height guys. Okay, h. So in first case here L and 15 is here width. Okay, and second case guys, see this one is a table. Okay, these are legs. Now the contact here surface is this one. Okay, this one is now width or this one is height. Okay, so in both the cases you have to find pressure exerted by brick on this table top. Okay, so in your mind one question arises, how the brick exert the force on the table. Okay, so guys, you know every mass on earth surface there is a force due to earth which is known as a gravitational force. Okay, so we can say the weight of the brick will apply the force on the table. Okay, because the force applied by earth on brick is its weight. Okay, we can also generalize this one. G, suppose mass of brick B and this one mass of earth, or this one RE square. So you know guys that GME or RE square equal to G, or this is MB into G. Okay, so you can say sir weight of brick equal to MBG. Okay, so here mass of the brick is 6 kg, or G value just we derived in earlier lecture, gravitation. Okay, this is meter per second square. Okay, this will come 58.8 Newton. Okay, so this weight will exert force. Okay, so guys, here see, the contact area is uniform. Okay, so pressure on table top when contact area is 20 centimeter into 15 centimeter equal to force divided by area. Okay, so you can say, sir, here force is 58.8 Newton or area 20 centimeter into 15 centimeter. Okay, so guys, can we write this one 58 Newton or this one 300 centimeter square? Okay, now see, this will come guys here, this one. Okay, or say PA. Okay, so whether this one is correct or wrong? Okay, so this one is guys wrong. Why? Because guys, you know that pressure unit is SI unit is Newton meter square, or this is also represented by Pascal. Okay, so where we make a mistake. Okay, so see, this unit is in centimeter square, so you guys need to convert it into SI unit. Okay, so we can put 1 by 100, this is m or this is a square. Okay, now you can see this one becomes guys what? Newton, or then this one becomes 300. Okay, or 1, or you can write 10 to power of 4, or this is meter square. Okay, so when you solve this one, this is coming 1960 Newton meter square. So you can say pressure is this one 1960 Pascal. Okay, in first case. Okay, now the second case, here see, pressure P equal to force by area. Okay, so guys, here force will not change because here the mass of any object is considered as a point. Okay, so it does not depends upon the shape in physics. Okay, so by changing the orientation, the weight is not going to be changed. Okay, because mass is a universal constant quantity, because it depends upon how much material is inside the mass. Okay, so material is not going to be changed. Okay, so this one is again mg, or now area. So here this is like this one, or now again the area we can write in SI unit. This is in meter now again, or this one now in meter again. So when you solve this one, guys. So this will come here 3920 Newton. Okay, so what we see or conclude, when the contact area decreases, okay, by factor of 2, see, this is 300 or this is 150 centimeter square, then pressure per unit area increases. Okay, so pressure is inversely proportional to area. Okay, so contact area is less, then pressure will be more. Okay, so next we will see the buoyancy or buoyant force. Okay, buoyancy, guys, before define the definition of buoyancy, first of all you know the term fluid. Okay, so fluid means which can flow, so gas or liquid both are considered as fluid. Okay, now see the definition of buoyancy. Okay, when a solid object is immersed in fluid partially or completely, then the upward force applied by fluid on object is called buoyancy or force of buoyant or upthrust force. Okay, now guys, here what does mean by partially immersed and completely immersed case? First of all you see. Okay, then we will discuss the force applied by fluid on object. Okay, see this one by an experiment. This one is a bowl in which water is filled up partially, not fully, because when the water will be at the top surface, then it will be fully filled up. However, level is less than from the top. Okay, so this is the partially filled bowl. Okay, now see one empty container here. Okay, when I leave it on this liquid, what's happen? See, some part of the container is in liquid, or you can say in water, and some part is out of water. Okay, so this one is a case of partially immersed object in liquid. Okay, now now see, this one is a coin, okay, or this one is a solid. Okay, how I leave it. Okay, see what's happened. Now you notice the 10 rupees coin is settled at the bottom of this bowl. Okay, so this one is a case of completely immersed object in a liquid. Okay, now guys, here you see the force of buoyancy, how the liquid apply. Now I closed this container or airtight. Okay, now see, I dip the container up to bottom level. Okay, now I apply a force. Okay, when I lift the hand again, the container come out from bottom to top surface. Okay, so how it is possible? Okay, so here the liquid applied a force on this container in upward direction, which is known as buoyancy or force of buoyancy, or you can say guys upthrust, force applied by liquid on container. See, okay, so hope guys now the concept of buoyancy clear to you. Okay, now next we see the Archimedes principle. Okay, what it say? So Archimedes principle it says when a solid object is immersed or dipped partially or completely in fluid, then upward force applied by fluid on object is equal to the weight of fluid displaced due to occupation of space in fluid. Okay, now so guys, now you understand the meaning of partially or completely immersed or deep of an object in a fluid. Okay, now here the word used fluid displaced. Okay, so what does mean by this one? First of all, you see guys, now see the meaning of fluid displaced. Okay, by putting a solid into it. Okay, now see, this one is a beaker. Now see, a full water glass. Now see, the water is at the top surface of the glass. Okay, now when I put one object on water surface, so what's happened? Notice, you see some water come out from the glass. Okay, so the amount of water come out from this glass is known as displaced water. Okay, so how much water come out? The volume of the container partially immersed in this liquid. Okay, so now you know the amount of water come out from the glass. See, when you wet this one, okay, then you will get the upward force applied by liquid on object. So this one is Archimedes principle. Okay, so next we will see the relative density and define the density and solve one numerical problem. Then the concept of weight of fluid displaced will be clear to you. So see, relative density. Relative density, it is ratio of substance density to density of fluid in which it is being dipped. Okay, so you can say in formula, relative density equal to density of substance divided by the density of fluid. Okay, so which fluid in which it is being dipped, or guys, here one thing first you notice, a relative density is density of the two density, so it has no unit or it is a number. Okay, now the second thing, when relative density is greater than 1, then object will completely immersed in fluid. Okay, now when relative density is less than 1, then object will partially immersed in fluid, or you can say float on liquid. Okay guys, uh, what does mean by density? Okay, you know it has a important role while solving the numerical problem. This is mass by volume. Okay, so guys, what does mean by density? Okay, so guys, concept of density you can understand by this way. Suppose this one is a cube, okay, its volume is V. Okay, so just you can see which one is more dense. Suppose here we put 4 balls, okay, or in this case we put 8 balls. Okay, so 4 balls, or here 8 balls, similar mass and shape. Okay, so what you see, in same volume, when more objects are occupied, then its density will be more, or wherever less object is occupied in given volume, then its density is less. Because see here, if we are talking about mass, then this volume have 8 balls, or this volume has only 4 balls, so mass will be more. Now volume is constant in the both the cases, so density in this case is more. Okay, now, so guys, now next we will see one numerical problem for your better understanding. Okay, see question guys, here question, a solid object whose mass is 1200 gram and density 6000 kg meter cube, and immersed in a fluid or liquid whose density is 2000 kg meter cube, then find out force of buoyancy acting on object. Okay, here solution guys. For solving the force of buoyancy, you need to find out how much liquid is displaced. Okay, when you know the amount of liquid displaced, then you know easily force of buoyancy acting on the object. Okay, so guys, see solution. Suppose this one is a container, if, okay, in which this object is here. Okay, like this one. Okay, so how much the volume of this object, the same amount of liquid will be displaced. Okay, so first of all you need to find out volume of object. Okay, so you know volume of object equal to what guys? Here mass by density. Okay, so you know this one V equal to m by rho, where rho is known as density. Okay, density V volume, or m mass of object. Okay, so we can put 1200 divided by 600, or this is 1 by 5, or this is meter cube. Okay, so guys, whether this solution is correct or wrong, think little bit. So my answer is, this answer is wrong. Why? Because see, the question is here tricky. Okay, the solid mass is given in gram. Okay, or the density is given in kg meter per cube. Okay, so you first convert mass into kg. So you write this one first. Okay, so this becomes divided by 1000, this is kg, so this is 1.2 kg. Okay, now volume v of object equal to here, see, this is in now kg, or this is now in kg, or this is meter cube. Okay, so we can write 1 by 5000 meter cube. Okay, or this kg unit cancel out, or this m3 is goes to numerator. Okay, so guys, always it is necessary to you start with writing the units, then you can not trap in the tricky question. Okay, just I trapped here. Okay, now so volume is known to you. Okay, so see what the volume occupied by the object, same amount of the liquid is also displaced. Okay, so you can write here mass of liquid displaced equal to what, guys? Now rho into v. Now rho is here 2000 kg meter per cube, or now volume is given 1 by 5000 meter cube. See, this is cancel out, or now this 0 cancel out, so this is becomes 0.4 kg. Okay, now question is asking about the force of buoyancy. Okay, so as per the Archimedes principle, you know, force of buoyancy equal to how much weight of liquid displaced by the object by fully or partially immersing liquid. So you can write this one. So weight of liquid displaced now, which is a force, so this is mg. So m value is 0.4 kg, or this is 9.8 meter per second square. So we can write this is equal to this 2, or this one equal to 39. Okay, now here this, so this is Newton. Okay, so weight of the liquid is 3.292 Newton. Okay, so buoyancy force applied by liquid on object is 3.292 Newton. Okay, so guys, hope now the concept of thrust, pressure, buoyancy force, Archimedes principle, partially and fully immersed of an object in liquid or fluid, and relative density now clear to you. If you guys think this lecture is informative for you and others, so please like and subscribe this YouTube channel, Foundation JEE. And one more request from guys, if you want to be updated for the next lecture, so please on your YouTube notification. So thank you very much for listening and watching this lecture. In next lecture guys, we will discuss about work and energy. So thanks once again. Have a nice day.